Hi everyone, welcome to this video. In this project, I am going to walk you through an end-to-end machine learning demo where I analyze how screen time affects the sleep quality. Okay, so this project is part of my internship selection task, and I will be explaining each step clearly from data loading to a model results. Okay, so let's get to the problem statement. As we all know, we all spend a lot of time on our phones, laptops, and screen every day. So the main question I'm trying to answer here is: does spending more time on screen actually reduce sleep quality or not? So from a machine learning point of view, this becomes a regression problem because sleep quality is not a continuous value. Not just like yes or no. If it is like just yes or no, then we can say it is a classification problem. So let's back to the data set. So here is the data set. For this project, I'm going to use a simple data set with two columns. The first column is a daily screen time measured in hours. So here is the screen time hours, and second column is a sleep quality score from 1 to 10. Okay, this is a sleep quality score from 1 to 10. Okay. This data set is clean, so there is no missing values, which make it perfect for a demo project. You can clearly see that there is no missing values. All the values are filled up. Okay. Now we back to the event before and just name as model. Okay. Next, I import some required Python libraries like Panda to handle the dataset, Matplotlib for visualization, and Scikit-learn for building and evaluating the machine learning models. So these libraries are widely used in real-world machine learning workflows. So let's get started. We first import Pandas as PD and import Matplotlib plot t scale model section put test split. This used to train and test the split for our data set. Then Scikit-learn also linear model that we're going to use as our linear regression for our given data set. Linear regression, then from Scikit-learn.matrices, we just import the absolute and also R square score that gives the accuracy and all. Okay, now then we simply load our data set and explore the data set. So we use the frame that is we can see that our data set is in for the form of CSV. So we just simply write it underscore CSV, and I simply just copy paste the name and can just write check that our data set is loaded or not. Yes, it is completely loaded. Okay. Now let us see that how much rows and columns are over there in our data set. So we just simply write f dot shape and also write f dot describe the id of we can say see that df dot shape, like there are over 36 rows and two columns over there in our data set, as we see over here. 36 rows and two columns. Okay, and describe like how many counts, then mean, then standard, then minimum, then maximum present over in our model. Okay, now next step is like feature selection and splitting. uh, we go to the data set, then um, here I separate a data set into feature and target variables. Like there are two columns, so we can say that one is an independent and second one is dependent. So we can say that screen time is basically our input feature, and sleep quality is our output feature that we are going to predict. Okay, uh, good. Just giving the name like x equals to df Screen time hours and work equals to here. It must be sleep underscore quality. Okay. Now we just simply run start first and test split along with the parameter of x comma y. The size must be 20%, so we can simply write 0.2 over there. The random state must be 42. Okay. Hmm. For the model training, I use simply linear regression. This algorithm is suitable because we are trying to understand between relationship of two consecutive variables. Okay, so one of these consecutive variable is this one, and second one is this one. Okay, so the model learns the mathematical relationship between the screen time and sleep quality based on our training data set. Okay, so we can say that model equals to that we are about linear regression and model dot fit training data set. Okay. Once our model is trained, I evaluate its performance using matrices like mean, absolute error, and R-squared score. Okay. So mean absolute error tells about how the prediction from an actual values on an average, while R-squared shows how well the model explains the variation in sleep quality. Okay. So we write y underscore predict equals to model dot predict of stage. Okay. It's simply mean absolute error or I predict. So, six for R square because R square is what score here also R score. Okay, from the cell here we can say that our mean absolute error is very low and R square score is 0.9, and it shows that our model have an accuracy of 99% while using our regression linear regression. So let us visualize and interpret using the Matplotlib. So for this plot shows actually the data points along with the regression line learned by the model. Okay, so we can say that plt dot scatter plot with x of I label of actual data plt dot show sigma dot experiment color must be say red clinic label without screen and that is in this. Okay, and then plt dot mobile develops quality. Title is time versus sleep quality. Okay, then we must I region to show our x and y in corner. Then we'll show Model. Sorry. Is the model.pd text capable. Type in so the error is like we have to plot not should. The TITLE, okay, there is a small TLE. Okay, here you can see that there is an actual data with along with a regression line. We can clearly see that regression line is like overlap with the actual data that is like exactly same over the actual data, so we can get this type of accuracy that is mentioned in R square score. And with our mean absolute error is very less because you can clearly see that there is a less uh, expand all the actual data are in a sequence line. There is no like other data like out of the range or exception, so we can clearly say that this is our model. So for summarization, in this project, I demonstrate a complete machine learning pipeline, starting from loading the data set, okay, to the pre-processing, to the model training. Here is the model training and evaluation. For this is the evaluation, then and visualization. So this kind of end-to-end workflow is commonly used in real-world machine learning application. So thank you for the watching.